MAN Takrov has developed a new generation of stacking and reclaiming bridges. These bridges are the driving force behind heap leach systems. Cutting-edge technology integrated in a new design concept optimizes these type of bridges and all linked components to a maximum. For ultimate reliability, MAN Takrov's design philosophy calls for bridge configurations, having as few components as possible. The crawlers power the bridges along. Crawlers are subjected to the static load of the bridge structure and the dynamic loads produced by equipment and material traveling on top of the bridges. For highest efficiency in operating and maintaining mobile bridge systems, MAN Takrov reduces the number of crawlers and bridge segments to an absolute minimum. In an on and off heap leach system, the stacking conveyor and reclaiming conveyor are running parallel between the two leach piles. These two conveyors transport the material for the bridges in and out of the heap leach area. The stacking conveyor carries the incoming fresh copper ore to the MAN Takrov stacking bridge conveyor. The stacking bridge continuously extends the head end of the leach piles via the discharging spreader conveyor. The MAN Takrov bucket wheel reclaimer removes the leached out copper ore, thereby shortening the tail end of the leach piles in a continuous operation. The MAN Takrov reclaiming bridge conveyor carries the redundant ore, also known as ripios, from the bucket wheel reclaimer to the reclaiming conveyor. MAN Takrov's mobile bridges are designed for stacking and reclaiming. A mobile bridge consists of one head segment, one tail segment, one center segment, and two identical intermediate segments. A minimum of 6 crawlers is required to support and transport these 5 bridge segments. The central bridge segment is supported by 2 crawlers. All the other segments are supported by 1 crawler only. The central bridge segment is freestanding. The adjacent segments are joined in accordance with Gerber's principle. Bridge segments are connected at their joints via a single pin. All crawlers are constructed identical. The crawler body is pivot mounted to a frame, which is an integral part of the bridge segment structure. A pair of leveling cylinders, operating in closed-loop control, prevent the structure from twisting should a crawler encounter sloping ground. A squirrel cage electric motor drives the crawler tracks. The power is transmitted via a cardan shaft and tractor-type crawler gearbox. The main body is running on travel wheels arranged 2-wheel bogies. The bogies are pivot-mounted, distributing the supported bridge load evenly to the crawler pads. Uneven ground encountered by the crawler pads is compensated by the spherical running area of the travel wheel, allowing sufficient inclination. The crawler pads are welded to casted links. All wheel bearings have sealed oil lubrication, similar to tractor-type crawlers. The electric motors of all crawlers have their frequency converters located in the electrical container at the center bridge segment. This location is most practical regarding service and maintenance. Not all crawlers require leveling cylinders. Only the crawlers of the head, center, and tail segments are equipped with hydraulic cylinders. They are not needed by the crawlers supporting the 2 intermediate bridge segments. Any torsion torque occurring in their region is compensated by the leveling cylinders of the adjacent crawlers on either side. Only 3 closed-loop controls are required to keep all bridge segments torsion-free and level. During bridge travel, the crawlers tend to move the segments away from a straight-line configuration. To keep the crawlers synchronized, any misalignment is immediately detected by MAN Tacroft's unique sensoring devices located at the pivot joints. A tensioned wire rope spanning across each of the pivot joints along bridge center line registers precisely unwanted movements. The rope deviates away from the pivot center by the slightest misalignment building up. The position of each wire rope is constantly monitored by an electronic sensor and immediately brought back to neutral by adjusting the travel speed of the nearest crawler. If a sensor malfunctions, an override limit switch shuts down the operation of the bridge and all linked components. A new sensor box is installed within minutes. The MAN Tacroft tripper-stacker combination is traveling on rails. The wheels have individually fitted gear units and are directly driven by squirrel cage electric motors. The travel speed of the tripper-stacker combination is infinitely variable via the drive motor's frequency converter. MAN Tacroft's mobile bridges can also be operated in manual mode. MAN Tacroft's new generation mobile bridge design reduces bridge segments, crawlers, and closed-loop controls to a minimum. Costs are reduced by servicing fewer components. Production is increased in having a smaller number of critical parts vital to the operation. MAN Tacroft's new generation mobile bridges, increasing the hours of continuous operation substantially.